Hey, YouTube, how is it going? I hope all is well. We are getting rolling on part 2 of this videos build series here, and yeah, we have a couple things to work out. This chassis is a little bit different from the original one that I used. I used an 8-inch one originally for this design. Well, I'm going back down to a 6.5. 8 inch is just a little bit bigger than it needs to be for this particular amp. So we're going to condense it down a little bit, which then means I need to do a little bit of redesign. Obviously, this amp is pretty much derived from a Marshall 18 watt, and obviously a lot of this stuff is fitting in the spots where it would normally with an 18 watt, such as the power transformer here, and the output transformer is very close, if not exactly where it would be. And I moved things around a little bit to fit how I wanted them to fit and lay out the way I wanted them to lay out. Now, with the 8-inch design, it was kind of inconsequential where I put the turret board. That guy there would end up kind of in line with that, and I just did it because it was simple, and it got this guy kind of in this area here. Well, I realized, and we're going to point out this a little bit here in a moment, but this guy here, I was like, I was trying to find a spot where I could fit it, and you can see I got a bunch of different lines and whatnot for that. But when I was looking at one of my other builds, I realized that standoff does not have to be where it's at. It can go, probably 5 holes in either direction, and not line up next to this flange for the output transformer, which is what I was trying to work around. So I was doing a little bit more work than I probably needed to get around that. When what I could really just do is put it where I want it, which is to have it line up off the center there. So I got some screws that go right here, right? And then right there is where the whatchamacallit goes. So that's where the screws go anyway. But I need it to line up right there. And it's just kind of nice because it falls in line with all the rest down the line. So because I don't have to have this here or there or there or there, I'm just going to move that standoff to a slightly different position. I'll probably move it this direction here, closer to where this one would be. So it's very well supported in the middle. In either case, where I was getting at with that is that it's important to make sure that you have all the parts that you need to do your build first. So that way you can kind of work this stuff out here. I got, obviously what are going to turn into drill templates for this thing that I have used already to make sure I have all these center punched where they need to be center punched at. So I've already gone through and I center punched the front and the back because I already know for a fact that they will work with the parts that I have. So there's that. So the only thing I had to work out was kind of how I wanted to lay things out on the top. Now in the original amp, they're about 1.5 inches from the edge. And then I space them about 1.5 inches from the outer edge, and etc. down the line. Well, I wanted to maintain some of the similar width that I had from my 8-inch design, or 8-inch chassis, if you will. So I shifted it from 1.5 inches out to about 1 inch. So that gives me pretty much the same width, from the pots to the, tube sockets, if you will. Maybe a 1/4 inch difference or something like that. But it allows me to center this guy very well between the things, so that way the wires that come off of either end are about the same length. And it's, instead of having literally like a 1 inch long length of wire or something like that, now I can have 1.25 inches or something like that. There's no need to have literally the shortest length of wire when it's too short to actually even do any work with. But so that's all the kind of stuff that I've been up to. All this tape is going to come off, and we're going to retape it so we can redo the layout, because now I know how I want this to fall. We can make it work. So I'm just going to do like a stop motion, if you will. Not even stop motion, what do you, a time lapse. We'll do a time lapse, so you'll see this thing just get cheese grated with more and more holes. And then, of course, we'll see the turret board getting built. And maybe later in the series, we'll stop and do some explanations about what's going on, why we're doing this or that. And then, of course, when we get to the actual firing up of this amp, we'll go through all the checks, make sure it's biased properly, and I'll, do all the things that we need to do and make sure that that is solidified in your brain. So that way, when you do yours, you don't have to worry. You already kind of know what you need to do. So stick around. We got more to come. We'll see you in a bit. All right, just a quick interruption here. Yes, I've got my Fosters, but just a quick interruption to kind of explain a couple things. I did a few things off camera just because they're just really invasive, and really you don't need to see it. You know that the hole is there, and you can obviously tell what the heck's gone on. I just kind of did some other things like getting the pilot light wired up. These guys here, these little red things, are for the LED driver. Use the protected ends like that if you're going to be doing what I'm doing here. This does have 120 volts on it, these things here. They're rated for that, so be mindful that, you know, everything's cool, but, you know, you do have to, you know, be smart. Make sure you cover those things up because those kibbles and bits are hot, or can be, will be. So yeah, the name of the game is to try to get all the noisy stuff as far over this way as you can. And as you can see, that's kind of what we've done. We kind of draw everything out that direction to get it away. The next thing that you'd want to do is try to run as short as practical runs. There are obviously ways to get things a little bit shorter, but this is practical, right? Just practical. This guy here is going to go onto the top of the turret board. Speaking of the turret board, I have this here. I did drill it out. I have already fitted it. I know that this is going to fit, so I did that. Obviously, I've tightened everything up now, so all the pots are tight. The input power and all these little kibbles and bits here are tight, with the exception of the cliff jacks. The jacks are going to be coming back out probably. These two here, so I can get some work done on the power tube sockets, and that one there so I can do all the wiring for the input jack and stuff like that. These guys I don't need to worry about having come back out because I already, we don't need to worry about that. So we are now at the point where we can finally get down to the kibbles and bits, the turret board. So I'm not going to waste any more time. Let's get to it. Hey, YouTube. How is it going? I hope all is well. We are ready to get down to the kibbles and bits, the fun of all fun times, firing up this amplifier. We are going to work together in real time on doing this. I do this in a lot of my videos, and I think it's just helpful, and it just drills it in your mind what you need to do every time you do this. So first and foremost, you need to go through your schematic and through your layout and just double check all the connections. Get this thing in beep mode and do any beepy that you need to do to make sure that all your connections are secured and that everything is touching the thing that it is supposed to touch. Doesn't take long, about 10 or 15 minutes or so, and you can suss out your entire circuit, especially if it's something like this. If you're trying to build like an angle or something like that, or a Mesa Boogie, well, you'll be there for an eternity trying to check all that stuff. But anyway, let's move on. So you might have seen these numbers down here. Those are the measurements of my output transformer, and it's the output transformer's measurement from the center tap of it to each of the plate leads. To do that, you put yourself in resistance mode, and then you touch in on the center tap, you wake back up, and then to each of the plates. It's been a little while since I did this, so the number may have changed a little bit. It's 309 on one side and 329 on the other. Earlier when I measured this out, it was 305 and 325. Doesn't really matter. That number will change depending on the temperature of the room. When I measured it before, the door was open and it was a little bit cooler in here. I've been in here doing all the checks to make sure that this is done and getting prepped for this video, and it has warmed up a little bit, enough so that my measurements have just changed a little bit. So we've done that now. We are actually ready to go into the voltage side of things, and we're going to check AC volts. We're not too concerned yet with much else other than the AC volts. So make sure your amp is in the off position. Get your power cord, plug in your power cord, and cross your fingers, because when you turn it on, you should get no sparky boom boom. Let's see what we got. No sparky boom boom. We are good. Obviously, if you've done all your your work and you checked everything like it should, turning the amp on shouldn't be too much of a problem. I apologize if you see any flickering. My ring light up here is starting to go on the fritz. Yeah. Anyway, I needed to go in low light mode, so that way this thing here, you could actually see it. And I can't say for 100% sure that you can, but I know for a fact you can't see it when I got my other light on. That does work. So what we're interested in is just a few volts, or a few voltage measurements. First and foremost, we want to see what we got coming into the amp. We have 118 volts coming into the amplifier. The next thing we want to know is what our HT is going to be. So that's these two, or our secondaries, if you will. That's these two red wires here. So we're going to go ahead and measure on that. And we just need to get some number. It looks like it's going to be 305.9 on one side, and it should be something relatively close on the other once I get the thing to hold still. Golly. 302.8. That's pretty close. It's not bad. The next thing we want to know is that we got heater voltages, where we're supposed to see heater voltages. So I touch it on one side, and the heater voltage for this guy is 7.16. Right? That's okay. There is no rectifier in... Oh, I should have mentioned. There are no tubes in the amp yet. They're all right here ready to get put in. So with no tubes in the amp, this is what you're going to do. I should clarify that. So there isn't going to be any voltages on the HT rail. The other spot that you want to try to make sure you got voltage, and you may as well just check at the very end, is your heaters for the preamp tubes. Now this will measure a little bit differently than the one for the rectifier, but you can see we got 3.3 on one side and 3.3 on the other. 6.6, no tubes in here. By the time we get tubes in, it'll be spot the heck on. So we are good at the moment as it is right now. So what we're going to do is turn the amp off, unplug it. We're ready to move on to the next part. We're ready to put in our rectifier tube. Oop. So let's go ahead and get our rectifier tube out. There we go. All right, so put this guy in real quick. Give me a moment here while I do that. If you wouldn't mind. Okay, so now we have our rectifier tube in. And we're going to do the same thing, except for now we're going to be in DC volts. So let's, whatever thing you have, switch it to DC. If you have this one's auto ranging. But if you have one of these styles here, like these older like Velmans, the regular ones, when you go into DC or AC, always go for the highest voltage available first. So 600 volts is usually the highest one that's selectable. That's the one you want to go in first. Don't go in the middle. Go to the highest one. Just to be clear. This guy is brand new to me. I literally just opened the box up today, so we're giving it a shot to see how I like it. There is a little bit of a learning curve for it, but whatever, yada, yada, yada. So, we've got our rectifier tube in now. Let's go ahead and plug in some power and turn on the amp. Now what we should actually start getting is some more fun voltages, right? We're going to actually start getting some high voltage in this amp in different places. But first and foremost, let's make sure we got glowing glass. I do see glowing glass. The next thing we're going to do is touch in here on our HT rail. And what we should see is some number. 420. Okay, not a big deal. That is okay. It's going to be about the same voltage all the way across, but what we're looking to see is that we have a voltage all the way across. We just want to know that we have voltage where we're supposed to see it. So we got 420 volts there, and even on the other side of this resistor here, it's not going to drop much. And it's not going to drop much because there is no current draw. Because there's no current demand in the amp at the moment, all the voltages are going to be relatively the same, and they're going to be relatively high. So let's go ahead and get one more voltage. We want to make sure that we see voltage also on our screen grid resistors here, or on this side of the screen grid resistor. We do. So we're good there. We are now ready to put in some more tubes. So let's go ahead and do that. So turn off the amp, unplug the power, and let's get some preamp tubes in there. So, ooh, it's starting to get fun, it's starting to get fun. We're getting to the real bit. All right, there's one. And if you don't mind, thank you. All right, so I'm gonna get these in real quick. Let's see here, you guys go that way. There we go. All right, so now we got two preamp tubes in. Turn back on, please. I don't like the timeout on that. I wish that would stay on, just on. I just want it to stay on, really. But whatever, we'll deal with that later. All right, so power, plug in the power, turn on the amp. What we're looking for is pretty much the same. We're looking just to see that the voltage is dropped. Now, the reason we're looking for a voltage drop is because then we will know that these preamp tubes are conducting like they are supposed to. How much of a drop? We don't know. I do see that they are both on and glowing, so we should just see a drop in voltage. And we are still in DC, and you can see we've gone from something like 420 down to like 385. So not bad, that's good. And it should be a little bit higher as we go down the line. It was about a 4 volt difference there or something like that. This is good. We know now that our output tubes, or excuse me, our preamp tubes are conducting. So let's go ahead and get ready to do the next fun bit. We are now actually going to start plugging in some power tubes. So let's go ahead and get our power tubes out here. And come on. There we go. Oh yeah, this came out nice today. I like that. All right, so let me get these plugged in real quick. And these ones are, if I recall, just a little bit. And the angle is different. There we go. There's one. And there's dose. There we go. Never mind the box. The box is to raise the amp up so that way the tubes don't hit anything hard. It's just to give them some air, I guess, if you will. All right. Now, because we are actually getting to the point now where we are going to have, well, basically the power tubes are in, and we're going to turn the amp on. we need to make sure that we have a speaker load. So make sure you got your speaker plugged in at this point, because we are going live with the amp. And since we're going live with the amp, we may as well plug in our input. That's why I turned down the volumes earlier. I got my tone knobs all the way up, so whatever. And what else? I think that's it. We're ready to go. Let's go ahead and take our power, plug in our power, and give it a go. So at this point here, what we want to see is, again, a larger voltage drop down at the end of the string here, or down at the end of the HT rail. So what we should notice is that this voltage here, ooh, I heard a pop, we got some life, is that it's going to be some other number. In this case, it's 324. It'll probably drop a little bit as the output tubes conduct more and more and more. And it'll settle at some voltage. I usually shoot for about 312 here. It's a little bit higher than I'd like. Not a bad thing though. 322 on this one. Let's see what we're at on this node. 325. Cool, whatever. We got voltage there. We know that we're doing all right. Let's see what our primary HT has dropped down to. We started at like 420. 358. I usually like it a little bit lower, about 10 volts lower would have been nice, but I'm not going to complain. We're not in a bad spot. I'm relatively certain that this will bias out quite well at this point. So speaking of bias, let's go ahead to our stream here of Rob Robinette's tube bias calculator, and let's punch in some digits. So let's find ourselves an EL84 right there. Let's go ahead. We're going to click on that, hit calculate. Let's go ahead and get down here a little bit first. Our cathode resistor is a 180. So let's go ahead and enter in 180. We'll hit calculate there. And then we don't know what this is going to be yet, but we're shooting for about 12 volts. And then up here, we know it's not 360 because we actually need to go plate to cathode. And our plate to cathode voltage is literally... And this one you got to get your fingers in, so get yourself some nice probes, and it's plate to cathode. So we want from here literally to the cathode, which is this guy here, and you see that we have 330. We're going to call it 338. 338 is a good enough number for me, so we'll go ahead and enter that on our Robinette calculator page here. We'll hit calculate. And we're going to see that we have essentially, we're shooting for about 34 milliamps per tube, 34 to 35. That's essentially what we're shooting for. 33.7 would also work, but okay, cool, whatever. So let's get that voltage drop across our cathode resistor. We can do that by literally just taking it to ground on one side and touching it here on the other. So we see here that we have 12.13. That is spot on. I love that. That is great. So we enter that on the tube bias calculator. So we get 12.1. And you'll see that we are exactly at 95%. Oh, that is exactly where we want this to be. So according to this, we should see about 31.8 milliamps per tube, roughly. Going back to those numbers that we talked about here, I didn't bring my calculator, so I'm not even going to try to do it in my brain. But if we look on here, we see that we take the measure, or we measure the voltage drop across the center tap to the plate. And so this one, you got to get a little bit brave because you are going to be touching the center tap. So we're talking several hundred volts, right? And get it to stand still. And the plate of one side, well, each side of the tube, but we're only doing one side at a time. And you're going to see that we had like 9 point something. Of course, it turned off right then. 9.47, right, or 46. So you take that 9.46 and then you divide it by the resistance. In this case, we had 305 on that side, and that will give you the actual current draw through that tube. And I can tell you right now, it's going to be about 31 point something milliamps. And then you do the same thing for the other side. So you go from that center tap right there to the other plate, and that'll give you another number. Let's go ahead and just do it. Let's see if I can get in there. There we go. and you can see it's 10.12. So again, you take that 10.12 and you divide it by the 325 ohms, and that will give you roughly the 31 to 32 milliamps that we got. We know that this amp is biased right where it wants to be. It's in the sweet spot. So, does it make noise? Let's find out. Oh yeah. All right. Our tone control works. Our master volume is working. Let's see if our preamp gain works. And then, of course, our bass cut. All right, so we know that works. Let's check our ohms thing here. You can kind of hear how it works. It gets brighter on one side, a little louder, and it gets, you know, normal. And then, of course, a little bit muffler. So there we go. We know that it makes noise. It sounds right on the money. Ta-da! We have a working amplifier. So that's how you do it. That is how we do the things that we do. So I want to thank you. We're going to do, obviously, probably a recap video at this point. That is it. We got ourselves a working amplifier. So thank you so much, and we'll see you in the next one.